Good evening, ladies and gentlemen. Welcome to the 11th series of Geosynthetic webinar under the theme Sustainable Application of Green Geosynthetics Engineering. This event is brought to you by International Geosynthetic Society Chapter Indonesia, which also known as INA-IGS. My name is Stephanie Bigel, and it's a pleasure to be the master of ceremony of this event. Before we start, please allow me to read the rundown of our event this evening. First, I will be reading the rules of the webinar. Second, there will be an opening remark by the member of INA-IGS, Mr. Insinyur Andrian Suhendra MT. After that, the event will be guided by Mr. Dandung Sri Harninto STMT. As the moderator to start the presentation of Professor Nelson Chou. The event will then continue with a Q&A session. After the Q&A session, we will be doing a quiz with a very interesting prize for the winner. So we would like to ask you to stay with us until the end of the event. At the end of the event, we'll also give you the access to the e-certificate, and that's all for the rundown of today's webinar. Ladies and gentlemen, for your own convenience, please put attention to the following rules and notice. First, you can submit your question for the speaker through the Q&A feature that's located at the bottom of the screen. The questions should be in English. You can submit your questions before, during, and after the presentation of the speaker. Second, we expect you to stay until the end of the webinar to get the information that you need, e-certificate, and also soft copy of the presentation from the speaker. This event is also live streamed on INA-IGS YouTube channel, or you can directly go to the link bit.ly/INA-IGS11YT. Fourth, if there's any technical difficulties, please contact Mr. Sandy at the number that has been shown on the screen. That's all for the rules and notice. Without any further ado, I would like to invite Mr. Insinyur Andrian Suhendra MT as the member of INA-IGS to give his opening remarks. To Mr. Andrian Suhendra, the time is yours.
Thank you, Stephanie. Good evening, ladies and gentlemen. On behalf of the Indonesian chapter of the International Geosynthetic Society, or well known as INA-IGS, I welcome you all to the 11th Geosynthetic webinar. This monthly webinar is one of our INA-IGS programs to share valuable knowledge from distinguished speakers from Indonesia and abroad to our members and, of course, our participants from everywhere, absolutely for free. This month, I'm delighted that we have invited insightful speaker with a presentation titled Sustainable Application of Green Geosynthetic Engineering. The speaker is Professor Nelson Chou from National Central University, Taiwan. I welcome you, Professor Chou, and thank you for your favorable knowledge and insight in this event. And I also welcome you again, all participants. Thank you for your participation in this webinar. I hope this webinar can be the best choice to get some valuable resources from geotechnical experts. I also thanks to all committee who set up this webinar. Please enjoy the webinar, stay safe, and thank you.
Thank you, Mr. Andrian Suhendra, for your kind remarks. Ladies and gentlemen, we would like to remind you that you can start submit your questions from now on by using the Q&A feature. We would also want to remind you to stay with us until the end of the event for the quiz session and to get the information regarding the e-certificate. Now, this webinar will be guided by Mr. Dandung Sri Harninto STMT as the moderator. Please welcome Mr. Dandung Sri Harninto STMT. The time is yours.
Oke, terima kasih Stephanie. Assalamualaikum warahmatullahi wabarakatuh. Selamat sore. Good evening, ladies and gentlemen. Thank you for your joining with us with our INA-IGS webinar. I think the event is already several times, and this evening we will have the very great speaker. He is Professor Nelson Chou from Taiwan. Okay, thank you. Okay, Professor Nelson Chou, before we start our session, I would like to read the profile of Professor Nelson Chou. Professor Nelson Chou has more than 40 years of practical experience in civil engineering, of course, including technical, geosynthetic, highway, and sustainable or green engineering. It's very good experience, especially with our topic about our topic this evening. We talk about the sustainable development. The academic background, Professor Nelson Chou already graduated from PhD in geotechnical engineering from University of Colorado, and now he is the professor at National Taiwan University and National Central University, and he is also visiting professor at Southwest Jiangtong University and Northwest University in China. And he is also former president of the Taiwan Geosynthetic Society, and then also former president of Synotex Engineering Consultant Incorporation, and also fellow of the American Society of Civil Engineering, fellow of Chinese Institute of Civil and Hydraulic Engineering. He also received several awards. First is in 2020 from Fumio Tatsuoka Awards. I think we know already about Mr. Tatsuoka is expert in geosynthetic structure also from Japan, as I know. From Journal of Transportation Infrastructure Geotechnology in the USA, and also award from as Outstanding Geotechnical Engineer Award from Taiwan Geotechnical Society. It's very great our speaker for our webinar. Before we start the webinar, I would like to, can you close Rifa? Okay. The title is Sustainable Application of Green Geosynthetic Engineering. As you know, that recently we have facing a great problem with our in our globe, of course, about climate change. We have the problem with ozone, with the rising of temperature, rising of sea water level, and so on. So geosynthetic become one of the alternative to exactly to replace conventional structure. Compare, for example, from concrete structure. Geosynthetic become more popular now, not only in Taipei and Taiwan. Indonesia also more popular for retaining wall, for road engineering, for coastal, for many applications now become wider application. Why using geosynthetic? As I'm not wrong, Mr. Chou, maybe you can correct me, during International Geosynthetic Society and the very great research from expert, he compared about the footprint carbon using geosynthetic with conventional. It's very interesting. Why interesting? Not only during operation, but during production, manufacturing, and etc. For example, right now when using concrete, using geosynthetic using less footprint carbon. It's very interesting research. If we can read the paper, it's very interesting. In total, if we are using geosynthetic technology, will be reduced carbon emission in our globe. And now, this evening, we will discuss a very interesting subject with Professor Nelson Chou about how we use geosynthetic engineering for sustainable application in our daily infrastructure we are using now. Now, okay, without further ado, Professor Nelson Chou, time and screens yours. About maybe 51 hours time will enough, and then we will continue with the Q&A session. Professor Nelson Chou, please, time yours.
Okay, thank you very much for your kind introduction, ladies and gentlemen. I'm very glad to be here to present to you the sustainable application of green geosynthetic engineering. Now let me show my PowerPoint. Okay, this is my presentation outline, and you can see there are some Indonesia language, which one of my Indonesia students in National Central University, he translate for me. I hope everything is correct. And so today I would introduce to you some, starting from introduction. Oh, let me get my pointer. Uh-oh. Pointer gonna. Uh-oh. I couldn't find a pointer. The cursor. No. It's not good. Oh, here. Okay. Okay, there's a point. Okay, this is a laser point. First, I would like to share you some green Reforesaur structure. Then geosynthetics for erosion control. Then will be next will be Geotube for water application. Then geosynthetic for low impact development or sponge city. I understand the Jakarta has suffered flood for a long time. I've been in Jakarta once when I was with Sinotech Engineering Consultant. We have a branch office in Jakarta. And then I would cover some other sustainable application and end up with conclusion and a summary. Okay, so first let me define what is the sustainable development. The sustainable development is development that meets the need of the present without compromising the ability for a future generation to meet their own needs. And also another definition is for green civil engineering. Green civil engineering is a civil engineering system or facility that is environmentally friendly and is the least damaging to the environment and the society in the project life cycle. Okay, this is my definition. Sustainable engineering and green engineering are similar in nature, but usually we define sustainable, we pay some more attention to durability, and the green put more emphasis on ecology and the environment. So in this presentation, I consider these two terms are the same and interchangeable for geosynthetic application. So for most of the cases, sustainable engineering and green engineering are the same, even though there are some slightly difference there. Recently, we published a paper trying to use 10 sustainable engineering indicator to evaluate sustainable engineering. Those 10 indicators including risk mitigation or safety, ecology, carbon emission reduction, energy saving, waste reduction, durability, benefit or function of the use of the material, and landscape, cultural preservation, and the creativity. By using this 10 indicator, I evaluate the geosynthetic application, and I rank geosynthetic either good, very good, or excellent, starting from 1 star to 3 star. For risk mitigation or safety, geosynthetic usually is pretty good. So from 2 to 3 star, very good to excellent. Ecology from 1 to 3 star. Carbon emission reduction geosynthetic application usually is pretty good, especially for reinforced soil structure. Energy saving, 3-star. Waste reduction, 3-star. Durability, also 2 or 3 stars. Benefit of function, 3. Landscape, from 1 to 3. Culture preservation, well, it depends. Most of the cases, geosynthetics, nothing to do with culture preservation, so I would say they're not applicable. And the creativity, yes, I think geosynthetic application are usually very creative. At least there are some new stuff coming from time to time. So I would say the creativity is. So among those 10 indicators, you can see the geosynthetic application either very good, either good or very good to excellent, except the culture preservation. Now I would like to show you the green reinforced soil structure. You see the bird here. Actually, bird is very smart. To see, he pick up a sprout of branches and mix with the soil, mix with a soil structure. It's a reinforced soil structure. And he also understand soil mechanics. So he put his saliva to make the soil partially saturated, not fully saturated, partially saturated, to increase the cohesion. And also he knows the structure. He built his nest in a arch shape, so can suffer the, either vertical or horizontal load. So the bird really know the principle of reinforced soils and also as well as structures. About 10 years ago, I visited the Great Wall in Han Dynasty, which is located in Western China. In Han Dynasty, which was it's about 2,000 years ago, they already built this wall with reinforced soil wall, and you see some straws and branches and reed and so on. Those are nature reinforcement material. And you can see from here, actually the soil structure can subject to bending moment. Usually we usually say soil cannot subject to any bending. However, once we build a gray wall, that becomes a structure, then it's subject to bending. So this is a Han Dynasty gray wall. If you look at some details, you see this gray wall actually built by compacted yellow silt or loss, sandwiched by nature reinforcing material, and in layers. For each layer, it's about 50 centimeter, which is about the same as we built a reinforced earth wall in modern days. And the ancient engineer, they find out by building this kind of vertical reinforced structure is most cost effective. And by using this reinforcement, the wall can be built vertically. And I also visit the Great Wall Museum to see what kind of reinforcement they use. Those are reeds, willow branches. So all those are nature reinforcement. And later, during the 1960s, a French architect, Vedel, he developed reinforced earth with steel reinforcement. Those are steel plate as a reinforcement. This was a project when I was in Colorado. We were involved. They built a reinforced soil wall in Vail, Colorado, and also use this kind of curve facing, which can subject to bigger horizontal force. We also built a test wall in Colorado, and you see the reinforcement is a geotextile, and by wrap around this reinforcement, we can, even though the reinforcement geotextile is relatively weak comparing to geogrid, which we are using right now, but you still can, even subject to very heavy load, the geotextile wall still can stand very well without any failure. And even we cut one edge, and due to the soil structure interaction, the rock or soil still stand there very well. So reinforcing material development, starting from the ancient Great Wall, tree branches, then go to reinforced earth, steel reinforcement, then geofabric reinforcement. Nowadays, we use a geogrid as reinforcement. And the geogrid reinforcement, again, we have various kinds with either two-way or one-way reinforcement. And also, there are several different types of wall facing. We call the mechanically stabilized earth wall, or MSE wall. Or sometimes we call geogrid wall or geosynthetic wall, geosynthetic reinforced wall, or GIS wall. They are about the same. Just depends on what kind of reinforcement you use. But anyway, we have 4 types of wall facing. This is full height concrete facing, which is popular in Japan, or called the 3-arm method. And that was developed by Professor Tatsuoka, and also very popular in Japan, the high-speed rail project. This is small segment precast panel, such as Keystone and so on. It's very popular in the United States and also some other countries. Or use a large segmental precast panel, like reinforced earth, also in United States. And this one is wraparound facing. We use a geogrid and put the vegetation on the surface, so the surface can becomes a large slope, and this is very popular in Taiwan. I'm not quite sure in Indonesia. I think Indonesia has a lot of water, rainwater, so that should be that could be used as well. And among those 4, I myself prefer to use this one. Not only cheaper without any facing, but also provide a green or ecological environment for vegetation as well as animals. So this is a typical vegetate wraparound facing reinforced soil wall or GIS wall in Taiwan. And you can also put some flowers if you want to. Okay, I do some comparison between the RC wall versus geosynthetic reinforced wall, GIS wall. Comparison item including cost. The RC wall, the unit price increased significantly with height. However, for geosynthetic reinforced wall, unit price is usually lower and non-varies with height. Appearance, concrete pooling, RC wall's concrete pooling surface, doesn't look right to me. But geosynthetic reinforced wall, especially for geogrid wall, is a vegetated surface. Design concept, RC wall is external stabilized wall, and the geosynthetic reinforced wall is internal stabilized. For earthquake resistance, RC wall is lower earthquake resistance, and the geosynthetic reinforced wall is high earthquake resistance. Okay, this I just show you the facing. Actually is not very important for Reforesaur structure, and those are without facing, the walls can stand up very well. So because it's internally stabilized wall. This Han Dynasty, and also Black Mountain, Black Stone reinforced wall in China. This is in Colorado. I just show you. Also, this picture shows the Reforesaur wall in Japan before the Osaka Kobe earthquake. And inside it is geogrid reinforcement, but on the surface in Japan, they put the concrete facing, we call 3Rs, RRR method. And it looks like concrete wall, looks like a concrete wall, but in reality, it is a geosynthetic reinforced wall. Okay, this picture was taken before the earthquake. And this picture was taken after the earthquake. You can see it, those are very, there's a not very tall building collapse. However, the wall was probably the same height, stand still without any failure. Only some settlement at the bottom because the soil underneath after shaking with some settlement, which is okay. So you can see the Reforesaur structure actually is very high earthquake resistant in nature. Okay, also we compare some other items such as the allowable settlement or deformation. RC wall, since it's a rigid structure, cannot suffer too much differential settlement. So either 1 inch to 2 inch settlement. However, geosynthetic soil wall can subject to 30 centimeter or even larger than 50 may be okay. Carbon emission, RC wall is much higher, and the geosynthetic reinforced wall is about 1/5 of the counterpart of RC wall. Okay, this picture is taken by Professor Lee of Taiwan Tech. That was 1989, before geogrid was developed. So they use geofabric as reinforcement. There's a wraparound method using geofabric as reinforcement. And this wall was built along the seashore, and the wave causing some settlement. Then the settlement, after maybe 1 to 2 meters, then the differential settlement disappear. You see, even though the bottom has some differential settlement, but here is pretty much level. So differential settlement does not affect the performance of geosynthetic reinforced soil wall due to some arch effect here. Also, I compare the carbon CO2 emission for various wall. And this is a paper written by Taiwan Tech students. They, it's a master thesis. It compared the gravity wall, cantilever wall, those are RC wall, and the wraparound geogrid reinforced wall. And the emission of carbon dioxide before and during construction. Before means during manufacture and during transportation, and during construction, probably several months. Then the gravity wall has 322,000 tons, and the cantilever wall, it's about a half. But the wraparound geogrid wall is much lower comparing to those concrete wall. Besides, during service, due to the vegetation and the emission of carbon dioxide becomes negative during the service, and only for wraparound geogrid wall. The other two doesn't have any effect. So add this together, you can see it, the wraparound geogrid wall is much lower CO2 emission compared to the other two. So that indicates geosynthetic is really a green structure. Also, in German, they did similar comparison. They compared the traditional construction method, which is concrete method, with reinforcing slope protection, and the energy and the CO2. It's also about 1/5. So they got the same conclusion. Okay, the surface of geosynthetic wall, it's easy to made of hydroseeding outfacing, and this is the case. I was involved in Qinan University in Taiwan. After we build a wall, we hydroseed the surface and make it lush. Okay, this is after. Okay, after construction, the complete slope facing, just like this. Since this is wrap around facing, there are some sandbags behind the wrap around portion, which provide some voids in between, and the voids is provide a biodiversity for the small animal, or also for the vegetation. So the wraparound facing, it's very suitable for either animal or vegetation. Okay, next section, I would like to discuss the erosion control. This is a this is a case. I was involved in erosion control and the stabilization by installing the geotextile, geogrid, geoweb, wire nets, and the soil nails. Okay, this is a landslide. Landslide, you see the water coming out. This is the original vertical drain. It's fall apart, and what we did is we install a layer. We dig a ditch then install a layer of geotextile, seen in white color. Then above that, we put a layer of geoweb. Then the geoweb is very light, so it's easy to construct. Put some nails to hold it. And this portion, we put the geograde. And also we put some wire net and put saw nail to hold it. So after several months, then the slope becomes like this. And the water still get into the geoweb web. So this provides a good environment, not only for the slope, also for water to get in. So we use this method to, instead of using any concrete structure or frame structure, and also becomes very cost effective besides to green environment. Okay, I also use the same technique in a project in Hubei, China. We use a geoweb as flexible ditch. At the bottom, we put a layer of geofabric to avoid erosion, and put this flexible geoweb as a vertical ditch. It's easy to construct, and also you can make whatever the size you want to. You can make 1 meter or whatever you need it. So the water can drain through this vertical ditch. Actually, it's not ditch; it's just some geosynthetic material, without using any concrete structure. And using the erosion control, also we use the geonet, the geotextile on the surface to allow the vegetation to grow up. After the geosynthetic and the fertilizer application, and the slope becomes like this. It's really a large slope. It's very beautiful. So officers are very happy with the achievement. As I mentioned, the geocell can be used for slope. Also can build a wall. So provide a beneficial environment for vegetation on steep slope. Geocell is very light in weight, easy for transportation and installation. This is during installation in China University, we use this. This is a saw nail head, using that as an anchorage for the installation of geocells. Also, okay, after we install the geoweb, then we hydro seeding on the surface of the slope. And about 2 months, it becomes a large slope. Vegetation grow up very well. Okay, next topic, I would like to cover Geotube. Okay, a little bit time lag. Okay, Geotube. From this picture, you see the shoreline erosion, which is very popular in some countries. And the old design is using trap pot, which is a concrete structure. And it's ugly. And also not very, it's really ugly and not modern design. And what is a modern design? Modern design is choose a geotube. What is geotube though? Geotube is a tube made of geofabric. It's a geofabric, and we pump the sandy material inside the tube, and the water will consolidate or coming out from this pervious geotextile. Then we keep on adding material, which is sandy material in most of the case, and the water keep on coming out due to consolidation. Then eventually geotube becomes a very solid and a heavy structure, and it cannot move easily. And so using this as protection for the shoreline. And the material of geotube is, most of cases, PP or PET, and the size, you can put the bigger one, becomes a geo container, but also small one as a geo bag. But the principle are the same. We also would like to compare the CO2 emission using geotube. Geotube made of geotextile and sand, and tetrapel is RC structure, and the rewrap is a stone structure. And the carbon footprint, if we assume geotube as 1, then tetrapel is 46, and the rewraps is 12. So by using geotube, we can save a lot of, we can reduce a lot of carbon dioxide emission up to 97%. Also cost-wise, we compare geotextile tube, geotube, and also the rewrap. And the rewrap, it's about the double of geotube. So it's very cost effective, which we used in protection of levied foundation at the Taiwan port in Taiwan. We can save up to 50% of the total cost. Also, geotube is very ecological friendly. You see the turtle here, they like geotube because geotube is very smooth and also very soft. They can lay down here to sleep without any sharp edge comparing to any concrete structure. Also, the fish like geotube. They swim around the geotube happily. Okay, next topic, I will cover the geosynthetic for low impact development. What is low impact development? LID definition is an approach to land development or redevelopment that works with nature to manage stormwater as close to its source as possible. Sometimes we also call the LID as a sponge city. In Taiwan and also in China, we call sponge city. In the United States, called LID. But anyway, we like to solve the problem as close to its source as possible. For instance, previously we we try to collect water from the highway, then we need a relatively large ditch here. However, we can allow water flow into the island and make a large island. And in that case, we don't need, or we use less ditch. So not only use less ditch, also make the grass much greener. Geosynthetic application in LID, low impact development. This is for bioretention, or called the rain garden. You can see here from this picture, this is infiltration age, then allow the water get into the soil, and we put the geotextile as a filtration. The water get into the sandy material, then go to the coarse material. And if needed, we can use a geotrain to let it drain out. But this may or may not need it. And also we put the geomembrane as a barrier on the boundary. Also, there are some application in storage. This is various kind of rainwater storage, underground storage. It's quite a few different kinds of design. One of the popular design is such. They built this kind of structure, looks like an arch type shape, and this is the single piece. Then the second piece above it, we turn around 90 degrees and make it like this. And then 90 degrees again. Then step by step, end up with maybe 10 meters. So this allowed water to store, and the efficiency is more than 90%. One case we have in Taiwan is, since Taiwan is very limited in space, we put 2 layers of storage. One layer is the upper one is the ecological or detention pond, which is located here. And the second layer, which is in lower layer, is geosynthetic water tank. And we allow the water flow from the surface. We pump and allow the water get into the water tank. Then coming out, make it circular. If the water is circular, then it's live water, it's not dead water. So it's good for ecology, but also for the water itself. And by using this technique, even though we have very limited space, but we can add water storage space. So I think it's suitable for a very crowded area like Taiwan, probably as well in Jakarta. Okay, next one, I would like to introduce a permeable pavement called JW pavement, which is developed from Taiwan. And this is it's different from the previous pavement in general, because they use the aqueduct to allow the water get into the storage, which is a gravel type of material. So water get into here, and the water can seep into the ground if the nature soil is a sandy material. But if it's clay material, then probably water will stop here. But anyway, this portion provide a good storage, but also this gravel provide a good bedding for pavement. So this pavement can subject to heavy traffic load, not just for sidewalk. Also the infiltration rate, the water can go through this hole easily because the hole is about 1 centimeter diameter. So the water can get in with very high infiltration rate comparing to normal pervious pavement. Okay, this is the principle of this permeable pavement. The water get through this hole, and the other hole with a smaller diameter at the top and the larger diameter at bottom. So the air will go like this, circular air. Circular air will make the temperature of the air about constant. So during summer, this is not very hot. During winter, snow will not accumulate. Okay, this water, this air, but also water can accumulate here. So actually we can put a LID, sponge city or water tank at the bottom of this, this portion and make it more storage if needed. The geosynthetic they use is recycled plastics. It's made of this kind of structure. Actually, it's a frame, but also with hole here. This aqueduct. Aqueduct, it's about 1 centimeter diameter for each connection, and also they put a cover. During construction of concrete, they don't want to let the concrete to get in, so there's coverage, temporary coverage. So this is a frame and also tube structure, and they are very strong, and one person can stand up easily. Also, then during construction, we put this kind of structure on the ground, and we fill concrete and press let it level. And after setup, we can, and also we can put some kind of surface artistic finish, either just this kind of color or make it some kind of special finish. Then after setup, we put up, remove the surface strip and to reveal those holes of aqueduct. So the water will get in to the storage, water storage through these holes. And the feature of this kind of JW pavement is it's both permeable but also load bearing. In other words, very heavy truck can go around here because the pavement itself is concrete pavement, and if we need it, we can put rebar in, so make it as strong as rigid pavement. And the water can get into here easily. The bearing capacity up to 10,000 pounds. So this kind of pavement can solve two problems at the same time. Permeability, also load bearing. Professor Liu of Taiwan University, he did some testing. He put a car to see how exhaust goes. Can the exhaust get into those holes? And he found out at least 50% of the exhaust from vehicle will enter the JW pavement within 20 minutes, and at least 70% of the carbon dioxide become nutrient of the underground ecological system. So this is very important because by using this technique, we can reduce the carbon dioxide emission, which is generated by vehicle exhaust. Okay, I move to other sustainable application. This is a reinforced dike used to prevent rockfall. The rockfall came from the mountain, and they hit this dike and remain or stay at the ditch in front of the dike. Since the dike is reinforced, but it's also very flexible, it can absorb the impact without damage. It's resilient. It's not as strong as concrete structure, but it's flexible and can absorb the impact. So when it may damage on surface, but the structure itself is very strong. Besides rockfall, it can also be used for diverting the mudflow. I designed a dike subject to mudflow, and the dike actually not very big. This mudflow came from the mountain. It covered actually, we built a tunnel, called cut and cover tunnel. However, due to the budget limitation, the tunnel is not long enough. It's not long to cover the whole area. So leave some room, which allowed the mudflow will go through here and causing some impact to the traffic. So we use this reinforced dike here to divert the mudflow. The mudflow come here and toward that direction. And also we use a detention pond as a storage for the mudflow. This is the project we have. The dike also provide a ramp for the vehicle and to maintain the surface, and also for this cut and cover tunnel. Okay, so this dike has several purposes, but at least that they can subject to horizontal force without damaging and stop the mudflow and toward that direction. And this is complete dike. You see the surface. The impacts came from here, and this is strong enough. And the surface is paved by concrete, and actually I don't see any crack of the concrete. So that means the dike itself is flexible, but also strong enough. This reinforced dike has been proved successful after several mudflow attacks, and turned out to be very effective and also very cheap compared to any other method. Okay, I also show you an interesting case by using reinforced floor structure for detention pond for a freeway ramp in Taiwan. Since usually when we built the freeway, this ramp we already acquired the land, so the land is free. But usually we just live there without any other benefit. But in this case, since there are some water, original some water coming through here, and we think try to enlarge the storage, use as a LID, try to store the water. Then we built a reinforced dike. Reinforced, it's called dike or reinforced slope or wall, either way. The depth about 10 meters with 2 steps. Here, we built a relative flat area, which has allowed the truck to come in to do some maintenance work. And this is the bottom, and the total height is about 10 meters. And this is during construction. They use the unsigned clay material as a backfill, and they even, since the original material is clay with gravel. Since gravel is more expensive, can be used for other purposes, so they separate clay with gravel, and the gravel was removed to other purpose. They're using clay as a backfill for this detention pond wall. A lot of people feel the clay material is not suitable for any near water structure. However, in this case, the detention pond, the water accumulation only maybe 2 or 3 days. And then after peak hours, the water coming out and within one hour, within one day. So the total saturating time, maybe 3 to 4 days. And if we use a clay backfill, then the backfill itself will not be saturated because the clay material has a low permeability. So turned out to be the clay backfill used for the geosynthetic wall. It's a very effective way to delay the peak time, and you can see from here those detention pond filled up. Then it delayed the peak time about 3 hours, and then can reduce flooding potential for the city. This is after construction. This is the ramp going down. Then can do some maintenance. Usually after flooding, there's some mud here. We probably to clean those mud coming out. Okay, I would like to make a conclusion. Sustainability is a harmony between man and nature. There are 2 very famous Chinese philosophers. One is Confucius, you probably heard of that. The other one is Mencius. Mencius said, "Take ox and a knife to mountain only in the fall, then the firewood can be used forever." So Mencius did not say you cannot cut any trees. He said, you can cut trees only in the fall, then the material can be used forever. In other words, there's a harmony between man and nature. By using this concept, we can allow the So allow the geosynthetic usage. It can contribute to sustainable development in a very broad area of civil engineering, hydraulic engineering, and environmental applications. So this is my summary. The last page, but not least. IGS going to have a Geosynthetic 7, GeoAsia 7, which is 7th Asia Regional Conference on Geosynthetic, will be held next year, October 31st to November 4th in Taipei International Convention Center. And I understand due to COVID-19, it's not easy to travel. And we hope sometime next year, the disease coming stop, and you may have the opportunity to visit Taiwan. And it's about 1 year ahead. Hope everything is fine. And you are welcome to Taipei to get a chance to see some of the project I present today. And thank you very much for your attention, and expect to see you at the GeoAsia 7 in Taipei. Thank you.
Thank you, Professor Nelson. Great sharing of the knowledge and information about how geosynthetic can contribute to sustainable development, not only in city and urban area as well, and also in remote also, of course. Once again, thank you, and a very great presentation. And I think we will have a very great discussion as well after that. Before, thank you. Before we go to the Q&A session, let me say hello from register by Krisandi. Now, our attendee is from more than 20 countries, Professor Nelson. So many our friends from not only from Indonesia, but also from abroad out of Indonesia. If we are take a look the name, like beside Indonesian name, yeah, I don't know, maybe the attendee cannot see, but because we are panelists, we can see the name, like Amy Wang, I think it's from Taiwan. It's correct, yeah, Mr. Nelson. And then the name from India as well attend in our webinar, and also the name like from Singapore, even from Turkey. It's good.
Oh,
Thank you for joining us. Yeah, really. And then from India, I see several names look like Indian name. It's great. Thank you from my friend from India. Thank you for joining the Indonesian webinar from INA-IGS. And then I see the Graham, I think the Germany, but it's still in Singapore, I think. This is from Germany also. Thank you for joining with us. And several names from Vietnam. I see the name, look like Vietnam name. It's great. Thank you for your joining with us. And I think this session will be good for sharing session. And also from Taiwan itself, from China, from Hong Kong, from Pakistan. I also see the name from Italy as well. Thank you. Great. Okay,
Original, I thought it's only from Indonesia.
No. Indonesia may be half, and the other is from others country, Professor Nelson. Okay. Because the subject may be so interesting. Okay, we go to the Q&A session. And then I think one question from Zolin. Zolin from China, maybe, I don't know. Look like from China. Only in Thailand.
From Thailand. Okay.
For the Thailand? From Taipei, yeah. The surface material were degraded. Should we use geosynthetic like geomat to cover of eroded surface? I think it's about the picture from Colorado, because the very ancient construction. How to protect? Protect the surface, so the surface not degraded bits. Then the first question, Nelson, I think 2 questions you can answer. And then about it's very good question about how to calculate CO2 emission, carbon emission to each construction material, like you say, because you, from your presentation, you compare between the geosynthetic reinforced structure with the conventional from concrete. For example, the amount of the CO2 emission is much higher. How to calculate? Not, in my opinion, not only in during construction, but also during fabrication of the material. For example, how to mix concrete, how to mix cement, and also compare how to mix geobit as the geosynthetic or for reinforcement. Okay, two questions first. First from Zolin and the second from Junata Chandra Gunawarin, I think from Indonesia. Okay. Please, listen.
Okay, first for the geotech reinforced wall in Colorado, the surface material will degrade. Should we use some geosynthetic like geomet or to cover the eroded surface? Actually, the surface is not really eroded. The sign wall is eroded, but not surface.
Yeah.
And, the sign wall usually we don't do anything because the material itself is reinforced by geotextile.
Mm-hmm.
So only the surface of the front surface, maybe 10 centimeter or something, it may coming out. But after that, it's okay because any reinforced soil structure will not collapse due to the surface. The failure zone is like a circular.
Ah, I see.
So just not on surface.
Yeah.
So usually we don't even try to cover anything. Okay.
Yeah, totally agree. Because the surface, yeah, the old structure is no problem.
Yeah, there's no problem. Just on surface.
Yeah.
Okay.
Okay.
How to calculate? Okay.
Yeah.
How to calculate CO2 emission for each construction material? Okay, actually, that's very complicated. CO2 emission, we call starting from installation, starting from manufacture. Manufacture, we calculate how much CO2 emission starting from manufacture, transportation, then construction step by step, then service. Okay, so this is it's actually very complicated. So it's not easy. I just answer you in one sentence because for each step, even including human behavior, it takes.
I know this is very complicated parameter variable to calculate exactly about the emission amount of every single step because
every single step we need to calculate. So not a very simple one. Actually, we consultant engineer, we spend a few months to do this kind of calculation. So it's not easy one. Okay.
Yeah. I agree. But as I mentioned in the very earlier, actually calculate every single, very complex, but it can be calculated with the good reasonable amount. Okay, thank you, Professor Nelson. And then we are move to the third and fourth, maybe one from Ray Petman. I don't know this name from Pakistan, maybe. How to install the soil nail on the steep slope as your presentation in the chapter Erosion Control. This first question about soil nailing application. I don't know if it's related or not, but this is the question from Ray Batman. And then the fourth, I cannot spelling very well. I'm sorry. Yong Ventaran Durai Semi. This is from Turkey, maybe. I don't know. How effective is geosynthetic material in railway embankment in the controlling surface erosion? And then what is the recommended type of the geosynthetic in railway embankment to avoid excessive deformation? I think as you mentioned, Professor Tatsuoka from Japan, many application, many research from him about the using geosynthetic for railway embankment. So please, Professor Nelson, about 2 questions.
Okay.
Yeah.
Let me say this question. The number 3 question actually is very interesting to me. What's meant by negative number of CO2 emission?
Okay.
Actually,
Okay. Just go ahead. No problem.
probably more. Yeah.
Yeah.
Usually we see only the CO2 emission. It becomes negative because during the service, the vegetation growth and vegetation itself, they emit some oxygen, and oxygen and the oxygen and the CO2, they are oxygen becomes negative for CO2 emission. So during the service life, depends on how long. At least
okay.
10 years, and if the service life is 50 years, then the oxygen provide more.
Okay. Become negative. Okay, because they are the construction contribute more oxygen to our nature, and then compare with the production, and then become negative. Yeah, that's good.
Negative is good. Okay.
Yeah.
Negative is good.
Amazing.
Okay, how to install the sonar on the steep slope as your presentation in chapter Erosion Control. Okay, sonars we usually install from the top to the bottom. From the top, we need some kind of anchorage. Usually, either using tray, or sometimes we use if there are some anchorage, we use that kind of anchorage. Then using safety belt to move from the top to the bottom, step by step, from the top to the bottom. And using sonar actually it's not a very heavy equipment comparing to anchor. So anchor, you need a very heavy machine. Sonar is not. So step by step. Okay.
Yeah.
But not everyone can do that though.
Yeah. It's not easy job actually. I ever done it. It's very not easy. Yeah.
How effective is geosynthetic material in railroad embankment in controlling surface erosion? What is recommended type of geosynthetic railway embankment to avoid excessive proper settlement? How effective is geosynthetic in railroad embankment in controlling surface erosion?
And also excessive deformation, Professor Nelson.
Surface erosion. I don't understand what geosynthetic materials in railroad embankment in controlling surface erosion. Surface erosion, you can use geosynthetic, but you don't really have to use surface. You're talking about the embankment surface, not top. Okay, embankment surface.
Yeah.
Okay, using GeoNet. I think I show one case. We put one layer of geogrid, then put another layer of wire mesh on the top of geogrid, then put the sonar to anchor to avoid sliding. I think in my picture use that. Okay. Geosynthetic railway embankment to avoid excessive settlement. I'm not quite sure. Did not complete the sentence, so I don't quite understand.
Yeah. Maybe about I don't know what's the question mean, but as you know, if we are construct the railway embankment, the deformation must be limited because of the using of the train. So what's maybe in my opinion, what we have to prepare so the embankment never have excessive deformation, Professor Nelson. Maybe with the soil treatment first before we construct the embankment, maybe.
Okay, actually, I think I show a picture. Professor Lee, he built the geofabric wall along the seashore, and you see the bottom has some there are some holes. Then the settlement did occur close to the bottom. But due to the anchorage, the geosynthetic becomes level after several. So even though there are some settlement, but by using of this geosynthetic material, the differential settlement can be level out.
Yeah,
it's not that critical. But if in case the foundation soil is very, very soft, then you need some treatment. Especially for the whole area, if the settlement just cannot be avoided. Geosynthetic cannot avoid settlement, but can reduce differential settlement.
Okay.
Okay.
This is the key answer. Okay.
In Japan, that the 3-art method geosynthetic wall was covered with concrete facing. Right after the earthquake, the wall itself stand very well, but it settled. Just cannot avoid settlement. Okay, settlement is a soil behavior underneath. Okay, so you cannot just reduce settlement, but you can reduce differential
settlement. Yes, exactly.
Actually, differential settlement is what we're really concerned about, not settlement.
Okay.
Okay.
Yeah, that's correct. Yeah, we cannot reduce, but only reduce the differential settlement. And if we can also using like prefabricated vertical drain to accelerate not only the development, also accelerate deformation during construction. So during operation, we will have no any deformation anymore. I mean additional explanation about the excessive deformation. So we move to the question about how to design using geoshell. It is any reference for us for design, Mr. Nelson. Indonesia also start using many of geoshell, but as long as I know, there is no standards how to calculate, for example, for basal reinforcement, for erosion protection. Any code from maybe from Taiwan itself, how to design geoshell is my additional question. Yeah, related the question from Miss Mila Kusuma Wardani. And then the second question about, I don't know, maybe you can answer or not about the what's geotextile and geogrid. Very simple question, actually. Maybe you can explain as well. And then the third about how long does geotextile geotube last? Because you have from your presentation, very picture about using geotube for coastal protection. Mr. Nelson, you can answer the 3 questions, please.
Okay, how to design using geoshell and any reference? Actually, not many reference about geoshell. Not much.
Yes.
According to Reforesaur strategy, geoshell is relatively new, and I think I'm not quite sure FHW have some publication on geoshell. And in Taiwan, we do our own. So I'm not quite sure we have some.
Yeah, it's still rare. Yeah.
If you
Yeah,
look
yeah,
at
I know.
so you can always find some.
Mhm.
But GeoCell is relatively new device, so I think you can always find some. But if I think probably Professor Connor, he published a book, Engineering Using Geosynthetic. I think in his book with some GeoCell information. I think it's pretty good.
Yeah.
Connor.
Yeah.
GSI. Okay.
Yes. Yeah, I also have a book about from Connor. There is, but not so complicated calculation, I think. But we can use for design actually. Okay.
Yeah, I noticed in China, they publish recently. They publish a Chinese book though. Cover some, but I don't know. You know, it's only in Chinese. So.
Yeah.
Okay. How long does the Geotube last? Why don't you compare the resistance tripartite with Geotube? Okay.
Tetrapod is from concrete.
Right. Tripartite is concrete structure.
Yeah.
And that material, even though it can last longer, probably longer, not quite sure. But Geotube, usually we put Geotube in layers. The lower layer is covered by the upper layer. The upper layer, we also cover with some material. We probably covered by soil material.
Yeah.
And we use vegetation on the top of soil. So,
yeah.
So it's not really subject to sunshine. So it's covered.
Yeah.
Once been covered, it can last for a long time.
Yeah.
The material itself, which is a geotextile. Okay.
Okay.
And sometimes we put the geotube layers by layers, try to build a high dike. And so in that case, even though the upper portion, the first layer, it may be subject to some degradation, but the second layer will be okay.
Yeah.
But we still try to cover it, the first layer, the top layer with soil, then with some vegetation. Okay.
Yeah.
Avoid sunshine.
Yeah. Yes, thank you. Right. Geotube is very interesting application, and also in Indonesia, many hydraulic protection, hydraulic structure using Geotube as well, Mr. Lusela, in Indonesia. Now we move to the next question about from Mr. Waskito about interested in GW pavement. Yeah, also I am interesting because you show on your picture how to make a hole in the pedestrian and the roads, and then the permeability is very high. How is the laying process of construction process? It is more effective compared to the conventional rigid basement. How it is cost-wise, maybe compared with other methods. And then about feasibility of future of use case improvement. It's good. The question about the GW pavement. It's very interesting picture you say. You saw to us, Mr. Nestor, about the GW pavement. Can you talk about that? Yes.
Okay. Let me read through this. Thank you for your great presentation. I'm really interested in the JW pavement. How is the laying process? Construction process. Is it more effective compared to conventional rigid pavement? How is it cost-wise? And the example of use case being implemented now, also feasibility of future use case improvement. Thank you for your response. Okay, the JW method actually is developed from
Hello? Hello?
This morning, and he said he talked to Indonesia, some officer, and Indonesia probably also interested in this method. Since it has a lot of information, I cannot just say one word, but my experience is this is a very good, very unique, innovative method to solve the water problem as well as the loading problem. And usually, if we can solve the water problem, usually pavement is very weak. On the other side, if provide a very durable pavement, that may not be effective for water storage. But this pavement with this tube, so water can get in easily directly to the gravel underneath, and then provide a good storage of water. Also, it's durable because this is just a concrete pavement. It's whole. Okay. So he said, is it more effective compared to conventional rigid pavement? If you compare the resistance, the belling, low belling, it's about the same. Maybe slightly lower because there are some holes inside, but they have some other option. Cost-wise, it's comparing to other permeable pavement. It may be a little bit higher in initial cost because they're made of concrete, also made of geosynthetic frame and the tube. The cost is a little bit higher than the conventional pervious pavement, either it's pervious asphalt or pervious concrete. However, it can last for many years. Don't need a resurface. You don't need to get rid of the surface and the resurface and so on. So it can last for maybe at least 10 years. Or even longer.
Okay.
The maintenance cost is much lower. So if we consider the life cycles, it's still really very cost effective.
Yeah. Okay, I think it's already answered the question. And then I think because the time, we almost 30 minutes for Q&A, but the last question from Michael Dobi. Thank you, Michael, and David Saputra. I think it's already related about. Thank you for a good talk, Professor Nelson. And do you have information about carbon emission from a wide range of construction material and processes? And I don't know, this Pak David posted the link to the about ABD system. Professor Nelson, do you have any suggestion about a question from Pak Michael Dobi about information about the carbon emission?
Okay. Actually, nowadays, there are quite a few material on this. If you look at the network, tons of carbon emission during construction, that kind of. Also, some manual provided from some consultant, English, as an English consultant. In Taiwan, we also have some in Chinese though, but it's easy to get those information from network. I don't think it's a problem.
Yeah. Okay. Because of time, Mr. Nelson, actually we already tried to answer all questions. Maybe we have to stop because already 8 o'clock and already 9 in the Taipei, I think. So once again, thank you very much for your share information, presentation. As I like to inform you that all kind of the application information of the system, some of them already using in Indonesia, already installed in Indonesia, like Geosynthetic Rainwater system, many application already installed in Indonesia. But some of them still rare. Rare, it means 1 or 2 application, and then also some of them never installed in Indonesia. It's very good sharing of your information about application of geosynthetic, considering about green engineering for sure. Okay, because we have to close the session. Once again, thank you very much, not only for Professor Nelson that already give a very great presentation and discussion, and also for attendees, already more than 100 people join with our webinar. Is very grateful, not only from Indonesia, half from Indonesia and half from abroad. It's very great. Thank you for all of you, my friend from others country, 20 more countries. It's very great. We can very easy to sharing knowledge. Not because if we are in the normal condition, we have to go to India, go to Taipei. Now we stay at home and have the very good information. It's maybe if we are invited, personal some come to Indonesia, we have to arrange about maybe 6 months later, before. Now we can just call, and then maybe next week you have time to 2 hours, and then we can share knowledge. Very easy. It's the goodness of the pandemic, Professor Nelson.
Okay.
Okay, before we close, maybe you have some message, some others advice to our all engineer, not only from Indonesia, because I inform you is many engineers from others country about our topic this evening, Nelson. Before we close the session, and I try to conclude all things. Please, Mr. Nelson, maybe you could have some message to us.
Okay, thank you very much for invitation. It's a really great experience to show you. Actually, I'm not that familiar with Zoom because in Taiwan we use Google Meet a lot. But anyway, this is good experience to me, and I'm glad to share this information to you outside Taiwan Island. If you're interested, I will remain my, I will leave my material with PDF form, and
Yeah.
I hope this will help for those people who are interested in this geosynthetic green application. And if you have some more questions, we can discuss some other time, and hopefully after the COVID-19 disease is over, then you're really welcome to Taipei to join the GeoAsia 7 held in next year, this time in Taipei. Okay.
Yep.
It's,
okay. Thank you, Professor Nelson Chou, for your message for to all of us. And of course, we do wish to come to Taipei again, because I last visit Taipei during RRC, I think 3-4 years ago, in Taipei as well. Okay. Hopefully next year, pandemic already go away, and can go and meet each other again and discuss more about all things about the geotechnical, about geosynthetic. So from webinar, I would like to not on conclusion actually, just a short comment that we are very happy. Why we have happy? Because all of us, I think, work in geosynthetic engineering field. Why happy? Because from the Mr. Nelson, Professor Nelson Chou explanation that when we are doing constructing using geosynthetic, we contribute to save our Earth. It is correct because we only produce very less carbon emission. It's very good thing for us. So this is the one message very important. So we do a lot with geosynthetic. We also contribute save our nation because using less carbon emission. And then from the Professor Nelson Chou explanation, many applications that's already shared to us, from retaining wall, from road construction, from hydraulic, from everything. It's good. All of them have the many data that state that using geosynthetic very good, green, and also less carbon emission. It is very important message for all of us. Okay, we cannot say more because a very fruitful discussion with Mr. Nelson. Once again, thank you very much. From your presentation is great, discussion is great, and thank you for your attendee already joined with our webinar. And see you soon with our INA-IGS webinar forum next month. Maybe from the Stephanie or Krisandi will explain about what's next, the discussion. Okay, thank you very much, Nelson, and see you soon. And in Taipei, hopefully we can meet in Taipei next year without any mask, without any PCR test before go into Taipei and have the quarantine about 2 weeks maybe. It's crazy.
Yeah, Taipei actually very safe.
Okay, I know.
very good cases right now.
Okay.
Almost zero.
Okay.
Nice.
Yeah. That's good. Indonesia also going better. There is some cases, but very little. It's great for us, but some country may be different. But Indonesia and Taipei now in very good condition in pandemic, and hopefully next year we can go to Taipei easily, and you come to Indonesia, Jakarta, Indonesia, so very easy as well. Okay, thank you once again, everybody. Back to Stephanie. Thank you, Stephanie.
Bye-bye.
Thank you, Professor Nelson Chou, for the presentation, and also thank you to Mr. Dandung Sri Harninto STMT as the moderator for guiding the session. Now we are heading to the quiz session that will be guided by Ms. Rifa. Please welcome Ms. Rifa. The time is yours.
Thank you, Stephanie. Ladies and gentlemen, good evening. My name is Rifa, and I will be guiding you in this very short game that we have prepared. And the questions are all prepared by our speaker, Professor Nelson Chou. The total prize is 250,000 rupiah. The first winner of the quiz will get 150,000 rupiah, and second winner will get 100,000 rupiah. But to give you disclaimer before we play, everyone, the attendees can join this quiz, but for technical reasons, only those who live inside Indonesia are eligible to get the prize. So, ladies and gentlemen, you can now directly go to your browser on your phone or on your PC and type menti.com, menti.com, menti.com. You have to type the code number shown on your screen, or also there in the chat box. The code is 74286408. Once again, please go to menti.com from your PC or your phone. Then go to menti.com and put the code 74286408. Then you can fill in your name and make sure that it is the name you submit in this registration for the webinar. So later, if you win, the committee will easily contact you for the prize. Remember, the prize is very interesting, the total of 250,000 rupiah, and everyone can join this game, but only those who live inside Indonesia are eligible to get the prize. You will not want to miss this chance, so please go to menti.com. We're going to play. There are 3 short questions prepared by our speaker, Professor Nelson Chou. And now, after you go to menti.com, you put the code 74286408 and fill in your name. If you forget the name that you register in the webinar, you can see right now on your Zoom, there's a display name. You can put your display name into the menti.com. Okay, you can see the code on your screen, and they're also on the chat box. The code is 74286408. Let's see how many people have joined us in the game. Okay, let me share my screen. We have 42 people. We're still waiting for others. You might not want to miss this chance, the total of 250,000 rupiah. Once again, the first winner will get, well, the total of 250,000 rupiah for the winners, but only those who live inside Indonesia are eligible to get the prize. Okay, I'm going to count down. We're still waiting. The code is 74286408. Still waiting. 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We're going to start the game. Okay. The first question, please answer fast to get more points. Among 10 sustainable indicators, which one is the least important for geosynthetics applications? Is it safety? Is it carbon emission reduction? Is it culture preservation? Or is it ecology? Sorry. So among 10 sustainable indicators, which one is the least important for geosynthetics applications? You still have plenty of time, but remember, if you answer fast, you'll get more bonus points. Is it safety? Is it carbon emission reduction? Is it culture preservation? Or is it ecology? You have 10 more seconds. I'll start the countdown. 5, 4, 3, 2, 1. Time's up. Let's see what is the correct answer. The correct answer is culture preservation. Let's see who leads the leaderboard for the first question. For the first question, the one who leads is Asmoni Yatub as the fastest one. But don't worry, we still have 2 more questions. Let's go to the second question. Without further ado, question 2 of 3. Answer fast to get more points. Which type of retaining structure usually generates the least carbon dioxide? First, gravity concrete wall, or is it cantilever wall? Is it concrete facing MSE wall, or is it wraparound MSE wall? This is already explained by our speaker, Professor Nelson Chou. Is it gravity concrete wall? Is it cantilever wall? Is it concrete facing MSE wall? Or the last one, is it wraparound MSE wall? Sorry. Which type of retaining structure usually generates the least carbon dioxide? 10 more seconds. I'll start the countdown now. 5, 4, 3, 2, 1. Time's up. Let's see. The correct answer is the last choice, wraparound MSE wall. Let's see who leads the leaderboard for the second question. For the second question, the one who leads is still Asmoni Jatub. Let's go to the last question. You still have 1 more chance to get the prize for 3 winners. Let's go, last question. Answer fast to get more points. Compared to the RC wall, the geosynthetics reinforced dike is more suitable for rockfall protection and mud flow diversion because the reinforced dike is stronger, more flexible, less expensive, or not afraid of water. Compared to the RC wall, the geosynthetics reinforced dike is more suitable for rockfall protection and mud flow diversion because the reinforced dike is it stronger? Is it more flexible? Is it less expensive? Or is it not afraid of water? You still have time to answer before time's up. Last question. This is your last chance to be the winners of tonight's quiz. Okay, let's see. Time's up. What is the correct answer for the last question? Is it the second option, more flexible? Let's see 3 winners tonight. Let's see the leaderboard. Well, congratulations. The first winner is David Saputra with 2,877 points. The second winner is Asmuni Jatub. And the third winner is Aflizal Arafianto. Later, the committee will contact you for the procedures to get the prize. Thank you everyone for playing. I hope you enjoy this quiz. Back to you, Miss Stephanie. Thank you.
All right, that's it for the quiz session, and congratulations for the winners. We would like to invite you to join the next Geosynthetic webinar series on December 21st, 2021 with the theme, Why is GeoGrid so difficult to model infinite element analysis? The speaker for the next webinar will be Andrew Lees. You can register via the link bit.ly/webinar INA-IGS 12. Once again, we would like to invite you to join the next Geosynthetic webinar series on December 21st, 2021 with the theme, Why is GeoGrid so difficult to model infinite element analysis? The speaker for the next webinar will be Andrew Lees. You can register via the link bit.ly/webinar INA-IGS 12. Would like to inform you that you can access the e-certificate and also the soft copy of the presentation from the speaker at the link bit.ly/info-INA-IGS11. Well, ladies and gentlemen, now we have come to the end of this webinar. It's been a pleasure being with all of you today. Thank you for your participation from the beginning to the end of the webinar. Hope we could see you in the next webinar. I wish you a very good evening. Always remember to stay safe and stay healthy. Goodbye and see you in the next webinar.